moving on to the next part of lecture number 2, we are going to discuss theory of light in view of scientific method. So first, Newton made a hypothesis about the nature of light. He said that light consists of extremely small particles moving with a very high velocity, and he called these particles as corpuscles. So these corpuscles, since they made up the light, so the theory is named after this and called corpuscular theory of light. And in this theory, he actually explained the phenomena of reflection and refraction of light and how the shadows are formed, and also backed them up by the experimental facts and results. Since his theory was accepted just because his experimental results for reflection and refraction conferred the theoretical results so the theory was actually accepted, and now this theory is widely used in optics, in the branch of physics. Optics as a basic theory is one of the basic theory of light and optics. In this theory, what he said that light actually travels faster in denser medium, and light travels slower in rarer medium. And we know it very well in denser medium. The reason is because in denser medium, molecules or atoms are so close to each other, so the light corpuscles can travel at less resistance and with high speed as compared to rare medium like air and denser medium like water or any solid. That's why we also say that light cannot pass through vacuum, because vacuum has no molecules. No, I guess that was about sound. Sound carries this. Yeah, black hole. It is actually. I just remember it is the black hole in which light cannot pass. Not the vacuum. Sorry about that. Okay. So this was his conclusion, and according to wave theory of light. Wave theory is another theory given by another scientist, and he said that light travels faster in rarer medium than in denser medium, and then the phenomena of interference, diffraction, and polarization of light, because of this, cannot be explained by the corpuscular theory of light, whereas the phenomena of interference, diffraction, and polarization was explained successfully by wave theory of light. So another scientist, Foucault, gave some experimental results of light traveling in water, and he calculated the speed of light in water, and he found that light travels slower in water than air. So this result was again against the corpuscular theory. Hence, corpuscular theory on the basis of the experiments of Foucault was disregarded or discarded, whereas wave theory was accepted. Then, with the passage of time, new phenomena were discovered, phenomena like photoelectric effect and Compton effect. Then again, the drawback of wave theory becomes, because wave theory says that light travels faster in rarer medium than in denser medium. Again, there becomes a drawback for the wave theory of light. Now, the Einstein came up with the theory of light and nature of theory of light, and presented his famous quantum theory of light. And he said he actually combined the previous two theories in a way that he said the theory is actually having a dual nature. It is both particle based and both light ray based, that is wave based. So on the basis of these two, that is, light can behave just like a wave as well, and light can behave just like a particle as well. And he called that packets of energy or particle of energy as photons or quantum or quanta in plural. So all the phenomena regarding nature of light now and be proved by the quantum theory of light. So this was the whole process, how the theory of light in early stages, in early years of the phenomena or the discovery was proposed differently. Then certain other scientists came up with certain experiments, then they disregarded the previous theory version and then came up with another new version of the theory of light. And then further, Einstein in the later years gave up his theory and he said, no, it is light is behaving in both ways.